So when it comes to magnetic effects of current, the name itself, if you see, name is magnetic effects of current. Okay. Okay. So when we have a magnet, there is magnetic field around a magnet. Yes or no? Yes, sir. Then when we talk about, we keep a all pen or some magnetic material near to magnet, then that gets attracted. Yes or no? Yes. If we get the same experience, same kind of thing near to a current carrying wire, then it is said to be a magnetic effect of current. What did I say? Means a current carrying wire, if it can behave like a magnet, then we call that magnetic effects of current. Okay. Like, all of you see to it. Can you see whiteboard?
Yes, sir.
Magnetic effects of current. All of you see one arrangement, and the arrangement is like this. Very simple arrangement was made, and this was made by whom? Anybody know this? Sorry, we had done this experiment. If we close this key, this is a resistor, this is the battery, and one key. When we'll close this, we'll get current into it. Very common. It's not something uniform, something which is unique, something different. Now, what was done? What was done? A magnetic compass was placed near to it. This magnetic compass is no way connected with the circuit, just placed very close to this circuit. And this arrangement was done by a Danish physicist named Hans Oersted, Oersted. So Hans Oersted did this experiment, and when a magnetic compass was placed near to this circuit, it was observed that this compass deflects. Deflection in this either left side or right side means this entire circuit behaves like a magnet. Okay. Okay. If 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 key is off, then there is no current, and in that situation, no such deflection in the galvanometer, which signifies that there must be current in the circuit. Then only such deflection is observed. And this phenomenon of deflection of this magnetic compass near to a electric circuit is called magnetic effect of current. Okay.
Yes, sir.
So all of you draw this circuit and write this name. Done, बच्चे?
Yes, sir.
Okay. Then all of you write the phenomenon of producing
Sir, can you repeat?
the phenomenon of producing magnetic field the phenomenon of producing magnetic field around a current carrying wire around a current carrying wire is called magnetic effect of current. Written?
Yes, sir. Yes, sir. Sir, can you repeat?
The phenomenon of producing magnetic field around a current carrying wire is called magnetic effects of current. Okay,
Yes, sir.
so core concept in this chapter, very first core concept is magnetic field. Okay, magnetic field, right? The space around a magnet, the space around a magnet within which its influence can be felt.
It's
The space around a magnet, the space around a magnet within which its influence can be felt is called magnetic field. Okay, symbol of magnetic field is capital B, and over capital B we put arrow mark. Okay, capital B and arrow mark. So B stands for magnetic field and arrow represent a vector quantity. So magnetic field is a vector quantity. Fine. Now next step is its SI unit. SI unit of magnetic field. When we write B vector, this represent magnetic field. Unit is WEBER, Weber per meter square, or this we also write in short WB, Weber per meter square. And then we have an absolute unit for this, which is called Tesla. Okay, symbol for Tesla is capital T. So both are used as standard unit, Weber per meter square or Tesla? Fine.
Yes, sir. Yes, sir.
Okay. Now let's do it. Let's try to understand it with the help of an activity. An activity is, let us consider, can you see this, what I have drawn?
Yes, sir.
This looks like what? Looks like square kind, na? Yes. And then this is actually not square. This is a cardboard. And through cardboard, we are passing a wire. Okay? Conducting wire. Fine. And conducting wire is connected with some battery, with a battery and key. And now let's switch on this key. Okay? When we switch on, what will happen? There will be current in this. There will be current in this. Let's say current is flowing like this. Fine. So current is going upward. Fine. Now, what we do, because this wire is passing from the center of this cardboard. This is a cardboard. Okay. Now what we do, you sprinkle some iron fillings around this, around this wire. Fine. If you sprinkle this iron filling around this wire, then it was observed that after some time, this iron filling is getting arranged around this wire. Not only arranged, this arrangement is in concentric circles. Are you listening?
Yes, sir.
These iron fillings are getting arranged, which was scattered here and there around this wire in, in concentric circles. See the magic happening. Appears to be magic. This signifies that around this state wire there is magnetic field, and that is why these iron fillings are arranged in a circle or in circles around it. Okay?
Yes, sir.
Okay. So all of you draw this. Done.
No, sir.
Now let us do Maxwell's thumb rule. What? Maxwell's thumb rule. Okay. All of you right? Maxwell's thumb rule to determine Maxwell's thumb rule to determine magnetic field, determine magnetic field around a straight wire. Maxwell's thumb rule. Maxwell's thumb rule to determine magnetic field around a current carrying straight wire. Okay. So let us take a straight wire and let's assume that there is current in this wire which is vertically upward I, and then make a circle around it. Okay. When you draw a circle around this straight wire and then put arrow like this, this direction of arrow is called anti-clockwise direction. Okay. What? Anti-clockwise. ANTICLOCKWISE. Anti-clockwise. Okay. Is what? Direction of magnetic field. Similarly, if you take another wire, in that, let us assume current is going down I, and then if you draw a circle like around the wire, then this arrow is clockwise. Okay, clockwise. All of you first draw this, then I'll explain what is this. All of you first copy it as it is. Copy it as it is. Aryan is there? Aryan?
Yes, sir.
Yes,
sir.
good. At least I know one name. Okay.
Yes, sir.
What is name of your physics teacher? Sorry? Is she there or not? Okay, okay. I'll speak to her later. All have drawn? Now, let us try to understand. All of you do one activity. Hold your pen in your right hand like this, the way I am holding this stylus. Let's say this is also pen, like this, such that pen is along the direction of thumb, but it must be in your right hand. Nobody should keep in left hand. Right hand only. Right hand, and then it should be, pen should be along the direction of this thumb. Okay, which means Maxwell told us if we hold a straight wire having current along the direction of thumb, then other fingers, means these curled fingers, okay, gives the direction of magnetic field, and this is anti-clockwise direction of magnetic field. Okay, and if you reverse it like this, now keep your thumb down along with the pen down. If you keep like this, now thumb is going down, so we assume that current is going down into the conductor through a conductor, but conductor is straight. Then the curled fingers gives the direction of magnetic field. Now the curled fingers are, these four curled fingers are in clockwise direction. Are you getting? Getting? Okay, good. Good. Then all of you write statement. Statement. Statement is when a straight wire when a straight wire carrying current is held in right hand when a straight wire carrying current is held in right hand such that thumb points the direction of current. Thumb points the direction of current. Then curled fingers, curled, C-U-R-L-E-D. Then curled fingers gives the direction of magnetic field. Then curled fingers gives the direction of magnetic field. Okay. Hope all have written and understood also. Understood? Then let us come to very important aspect of this, which is called magnetic field lines. Magnetic field lines. So magnetic field lines, okay, or magnetic lines of force. Two names, both are same. Okay, magnetic field lines or magnetic lines of force. What does it mean? All of you try to understand first. When we talk about a magnet, okay, when we talk about a magnet, then there is certain area of influence. Is it? Yes, no? Means up to certain area, magnet can influence an object or magnetic material. In this domain, if you keep a ball pen or other magnet, attraction, repulsion can be observed. Okay? But if you go beyond the domain, then it might not be attracted. Fine? Fine? So around a magnet, this domain is shown with some imaginary lines. Which lines? Imaginary lines. These lines are not the actual lines, but these lines depict the magnetic field around a magnet. Are you getting? Anybody can repeat this? Anybody can repeat this? Imaginary lines around a magnet which is used to depict the magnetic field. Okay? Okay? So all of you write this line. All of you first write one line. The imaginary lines, the imaginary lines which is used to depict magnetic field around a magnet is called magnetic field lines. Is called magnetic field lines. Okay. Okay. Now let us do one thing. Let us draw these lines and then we'll be able to understand it in a better way. So all of you give heading magnetic fields, rather magnetic field lines around a bar magnet. Magnetic field lines around a bar magnet. Fine. So let us have a bar magnet. Let's say, okay. And let us show the north and south poles inside a magnet. And then two horizontal lines from north and south poles. This arrow is coming outward from north side, and over here arrow is going inward. Don't make any error while putting arrows. And inside this we'll be putting it from south pole to north pole. Okay. And then we draw like this. While drawing these lines, again I am repeating, arrow marks should be given properly. Now try to understand, then you copy. First thing is, these lines are not touching each other, must not touch each other. Point number one. Point number two, outside the magnet, it moves from north pole towards south pole. Inside the magnet, it moves from south pole to north pole. And left and right side, the horizontal lines from north, it is away from the line north pole, and from south it is towards the south. Okay, so these points are to be taken into account when we draw field lines. First you draw, then we'll be doing some properties of these lines.